Hey everyone, this is Michael Lee, founder of the Data Incubator. We're a data science training and placement company, so we help people both hire and train their data scientists. And you probably have heard about us through our fellowship, where we get PhDs, master students who are applying to join this fellowship. It's totally free for the fellows who get in, and if you're interested in learning more, you can go to www.thedataincubator.com to learn more. And of course, if you're a working professional and you're also looking to learn a bit more about data science, perhaps at nighttime or on the weekends, you can go to see our online courses. And that's also available at www.thedataincubator.com. So today, we're going to be doing another installment of Data Science in 30 Minutes. This is a regular monthly series on data and its impact in the world. So past speakers have included Kirk Bourne, the Director of Data Science at Booz Allen Hamilton, Holden Corral, an engineering lead at IBM and one of the core contributors to Apache Spark, Zubin Garmani, the chief scientist at Uber, Sam Swift, the VP of Data Science at Betterment, who was also a former TDI fellow, and many, many more. So if you're interested, you can go to our website, check out our blog, we can read more about them, and you can also sign up to see those episodes and also see what future episodes we have. Now, before I introduce today's speaker, I want to remind everyone that you can pose questions in the YouTube chat area. That's kind of on the bottom right. You'll have to be logged in to your Google account to be able to do that. And we'll be monitoring those questions, and we'll be posting them to the speaker at the end of the talk. And so without further ado, I'd like to introduce today's speaker. So Carla Gentry is an expert in the field of advanced analytics and data science. And over the past 2 decades, she's worked for Fortune 100 and 500 companies, name brand institutions like Discover Financial, Johnson & Johnson, Hershey, Kraft, Kellogg, Disney, and Deloitte. And she'll be speaking about ethics, privacy, and security. So without further ado, Carla, you want to take it up from here?
Yeah, well, thank you so very much, Michael, and it's my honor to be welcomed and join you guys. You do a lot of wonderful things for data scientists, and that's the thing. You know, data science has become an integral part of the business world. This is something that we need, not just for Firestone and Deloitte and Disney, but we need this for smaller firms as well. You know, perfect example, you're spending, say, $100,000 on Google Analytics per year, but yet you don't feel like you're getting, a bang for your buck. I mean, you should be able to be data driven. You should be able to look at your analysis and see where you're spending your money and then maybe move your money around. I'm not getting a really good ROI here. I should move my money. But most people don't understand. They apply and they get Google Analytics because they know they have to look at their metrics for their analytics, but they don't really truly understand what it is. And that's kind of what data science is about, understanding the data. You know, I have a lot of people that come up to me and they're like, Carla, what should I use for programming? And I always tell them it doesn't matter. Whether you use R, you use Python, you use Perl, you use SAS, you use SPSS, you use MATLAB, you could use Excel. I mean, whatever you use be able to glean insight. And what I mean by that is, don't just create charts. Tell a story with your data. Tell, how we can make an impact on the business. So when we're looking at these metrics, tell how these metrics tie back to the money that we spend. Tell how these metrics tie back to the talent that we hire or we train or we, on board. I mean, a lot of people spend, billions of dollars a year on training to be able to assure themselves that they will have good employees. But it's not just necessarily just the training, it's finding the right person for the job. And how we do that is through analytics and data science and, surveys and assessments and things like that. And then in cooperation with artificial intelligence and machine learning, we can actually find more people like, the good employees that we currently have, personality wise. Now we have to be careful about, AI and machine learning, because these buzzwords can be dangerous as well, because if you're letting the data move you in one way or the other based on gender or race or ethnicity, then you should stop right now and take those variables out of your model. They say that a model can't be biased, but it can have biased information input into it. So it's not the machine that you have to blame, it's the variables and what you're actually teaching the computer. So like Google did this, they went back, they did an analysis, and they saw, and it was an early analysis from when their staff was mainly men, predominantly, male employees. So when they built an algorithm, it overlooked the women and only hired the guys. So we have to be careful that we let the data speak. And what I mean by that is it doesn't need to be interpreted. It can stand alone. Like we all know that 2 plus 2 is 4. Those facts stand alone. So if an employee coming in has got a bad work record, that stands on its own as well. But we should not be looking at anything specific about that person other than their talent. I mean, I know that there was a penal situation up in New York where the prison system was using an algorithm to be able to do early release on prisoners. And there was a problem. So, I mean, if you don't take out the bias and use your machine learning and AI ethically, then you will be sued later, because these have impacts. So you have to think of these data points as being human lives.
Yeah.
So say, we're looking at credit risk. Of course, a credit risk is an algorithm. You're looking at their FICO scores. You're looking at their past, the history of their credit and things like that. And that's what's been done for decades. I mean, when I joined, I actually worked for Ronald J. Crum and Associates right out of college, and it was an econometrical consulting firm. And our first client was Discover Financial Services. And Discover Financial Services, of course, is credit card, credit risk, and things like that. But it was also about allowing people to get affinity cards, which are similar cards, to increase their credit line. So now instead of having one Discover Financial card, you've got 2 or you've got 3. So if you become a good customer, now they know that they can trust you and they want you to spend more money. So things like that are measurable, that stand alone, like FICO scores and credit risk, these don't have to be interpreted. So, but when you start looking at, like, a woman who is in her 50s, then you start talking about, well, maybe gender bias, and now you're looking at her age. She's 50. Oh, now we're looking at age discrimination. So with businesses need diversity. They need to have, everybody without regards to their gender or their sex. I mean, talent is talent. And that's what we want in companies. We want to be able to find that talent.
So let's talk a little bit about those algorithms, right? I mean, I think one of the things that we see is, okay, so you have a credit algorithm. You're not necessarily going to explicitly discriminate on the basis of race or sex or any protected category. But I think one thing that's well known is that you can introduce that through kind of a backdoor, right? Say if you have geography as a variable, zip code.
Code.
Yeah, exactly. And so the trick there is that, well, based on the kind of segregated, de facto segregated residential, the state of the U.S. residential environment, we see that actually, if you use zip code, you could de facto discriminate on race, right? Because there are going to be zip codes that are predominantly of one race or ethnicity and zip codes that are of another. So do you have any advice for how do you detect, prevent, this kind of, let's say, backdoor bias?
Well, I think that, to your point, I think that you strip that out. I think that you let the information that can stand alone, I mean, you can look at state and city, but I don't think that you need to get as granular as a zip code. But then, because you start making assumptions, then you're like, oh, okay, they live in that zip code. Well, we know what happens there. Well, don't imply anything. Like previous to, I recently I've stepped away from my own business, Analytical Solution, to take a position at Design Interactive Incorporated in Orlando, Florida. I took a position with them as their data scientist. But before I came to Orlando, I've been here 3 weeks now, but before I lived in Louisville, Kentucky. And the zip code that I live in has a multitude of different people. I mean, you could not make an assumption based on just looking at that zip code, because we have retired people. You have, people that have lived there for a long time, but they passed away and left their property to younger, like grandchildren and things, which may or may not, be, let's put it this way, they may have had some problems with the police or with alcohol or drugs, but that doesn't, mean that just because a bad person lives in that zip code that you should make assumptions about the entire zip code. They also have very wealthy people that live in that zip code. But to your point, I mean, you could take, like if you're looking at New York and you went into the Bronx and things like that, and you started saying, oh, well, we shouldn't loan people this because they live in a bad neighborhood. Really, you take out those factors that have anything to do with what's considered the protected classes. Just like businesses and jobs and restaurants and things like that are not allowed to discriminate on age or gender or ethnicity or sex, I think that we have to keep that same approach when we build a model. Because when we put these potentially biased variables into the mix, that's when we set ourselves up for failure. Because if we're looking at a model, we have a lot of variables out there that we can look at about people, their spending habits, their buying habits. What are they doing on social media? Are they on Facebook? Are they on LinkedIn? These are other things that we could do that would not be biased. They would not imply unethical issues. And then, of course, you have those people out there that want to cause harm and to hack other people's computers and things like that, which is one of the things we're also talking about, bias and privacy and ethics. So our data scientist has to think like a CEO. He has to think like an IT person. We have to protect that data. If we have data that we're, siloed data or something like, maybe look at, protecting that data or recoding that data in such a way that it couldn't, even if someone were to steal it or hack into it, that they wouldn't get vital personal information. We have to protect our PI or our personal information just like we would protect our home and our children and our families, because, like I said, these data points are human beings. So I think if we think like a business person and we put many hats on, and it's not just about programming, it's not just about modeling, it's about people, and think like a chess player. There's some very famous chess people out there that said that they always think 5 moves ahead. So when you're building something, try to think ahead. How will this be used? What are the potential dangers that I could face? How can I protect this data through obfuscation, or, in other words, obfuscate the data, hide it in some way, or make it so that when they see it, it looks like a bunch of characters. That way they're not going to get your address, your city, your state, your bank account, any of this.
You work with a bunch of organizations. What are some of the best practices that you recommend in order to protect from these ever more kind of alarmingly common data breaches?
Well, my first recommendation is always obfuscate your data. When you're talking about bank data, that data is obfuscated. So it's stored and held, and whether it's in the cloud, whether it's in AWS, or whether it's on a server somewhere, that data is protected. You have to make sure that you let your IT people do their job. Your chief data officer or your chief IT person has to be the one that sets up these protections. And we have virus protection. We have, ways to block this information, but then people get frustrated or they get lazy. Oh, I'm going to just email this database to somebody, or I'm going to put it up on Dropbox. Dropbox has been hacked. So, we have to think of ways. And here's the best thing. If you want to save your data, hook an external drive up to your computer, save all of your data on that external drive, and then unplug it. And when you disconnect yourself from the internet, now nobody can get at that data. I mean, there's just small things that you can do to protect yourself that will keep people out of your computer, out of your servers, out of your Dropbox account. And please be mindful when you use your passwords. Password is not an option, and password 123 is not an option either. I mean, make these things very difficult. Use special characters. You make them very long. They can be 9 to 16 digits. I understand that people say, "Oh, well, I'll forget it." Well, take something that you'll never forget and then add a bunch of characters to it and write it down somewhere and tape it underneath your desk. I mean, like, protect that like you would protect the gold in Fort Knox. Because this information that is gold. We data mine to be able to get the gold, which is information. It's not about Python. It's not about, Perl or R or any of these programming languages. It's about gleaning insight from that information. Now, once you've gleaned that insight, now you need to protect that information. So, don't be, sharing data via email. Don't put it on Dropbox. Make sure that you do, if you have a SharePoint account or using something internally within the company, that you follow the rules and the regulations that your IT staff has set out for you. They don't make these rules and regulations just to be a pain in your butt and to annoy us. They do that to protect us. Now, the best bet is two-factor authorization, because that way, if you're trying to log into something and you're not the person, that second point of authorization, whether it's your cell phone or text message or email, will assure that it's you. Does it take a couple extra seconds? Yeah, but isn't it worth a couple extra seconds to be safe?
Yes. And we've one of the things that's become kind of a hot topic now is this notion of adversarial attacks, machine learning and deep learning models. Do you want to explain that a little bit? And maybe talk about how organizations, well, one, that organizations should be aware of this, but two, how they can defend against it?
Well, I mean, there's things called a data poisoning attack, and the data poisoning attack refers to someone systematically changing your training data to manipulate your model's predictions. So say you had built a model, but you have it on a place that's not protected. Someone could actually change your data, change your model to be whatever they wanted to. Brute force attacks like DOS attacks. That's forces, you're forcing so much information at one time that the IT department is not able to handle it. And I know a lot of times, like when Facebook or Twitter goes down, they usually say it was because of brute force attack. You also have what's called disparate impact analysis, where many banks already undertake disparate. That's when I say disparate data, that means like you have all of these different data files, but they don't connect to each other. They don't have a unique quantifier to be able to kind of join the files together. So a lot of times think, well, it doesn't have anything that could connect to anything else, so we don't necessarily need to protect it. But, and there are several great open source tools for detecting, like discrimination and disparate impact analysis. So there are ways that you can get around these. I mean, residual analysis, you want to look for strange things that's happening, like and this is what IT would do. They would look at their logs to be able to see what's going on within their own system. So there's watermark attacks, anomaly detection, data integrity constraints. So, inversion control issues. So, inversion by surrogate models. So, I mean, you could do an inversion basically refers to getting unauthorized information out of your model as opposed to putting information into your model. So, aversion can also be an example of an exploratory reverse engineering attack. So there's more than one way to actually get into someone's system. It's not just about virus protection all the time. It's about these brute force attacks. And hackers have come a long way in the last 20 or 30 years. And I always wish for as brilliant, as smart as these people are, hackers, that if they could do good, with this hack, this thing, this incredible, ability they have to get into other people's computer, if they could use that for good instead of bad, think about, the possibilities of what they could potentially do. But a lot of times companies will actually hire hackers because it takes a hacker to start, if you know what I mean.
Yes, yes. Yeah, I mean, I think this concept of a white hat hacker is a popular one now. And I think more and more companies are starting to use that.
Yeah, well, there's like white hat surrogate models. So as a white hat hacking exercise, you could train your own surrogate model between inputs and the prediction of your productivity model, and then carefully observe. You have accuracy bounds. So, the accuracy bounds of different types of white hat surrogate models, then try to understand the extent to which a surrogate model can really be used to learn unfavorable knowledge about your model. So, it's definitely interesting, and the rules that can be learned from a white hat surrogate decision tree, for example, like how to imply reliability and how to impersonate an individual who received something. So you could actually, they've gotten to the point now where you can clone IPs and you could actually impersonate someone. That's a lot of times when you get your Twitter account hacked, you'll see that they've lost their account, and then you go and like, hey, what happened, to so and so? It says on here that there's some suspicious activity on their account, and that's because it was hacked, and what was coming out of there wasn't along the lines of what they normally would share. So I think, just keeping an eye on what's going on. I mean, and it's not just about a daily thing. You have to look at it as a trend. So if you looked at a week of data, and you saw spikes, that would let you know that something was going on, whereas you may not necessarily see that trend or that spike if you're just looking at one day. So, that's the thing about, looking at time series analysis data, because then you actually start to see trends of activity, whether it be fraudulent activity or, hackers getting into your system, because even IT departments use time series analysis where they're looking at what's going on with the system over a period of time.
Yeah, got it. No, I think those all make a lot of sense. So one of the questions the audience is posing is, how do we recognize bias? So we're training these algorithms to screen resumes, to do credit scoring, what have you. And we know that maybe they can have bias. How do we detect that? And how do we, it's one thing to say like, okay, fine, there's 4 protected categories out there, right? Like age, sex, race, you enumerate a few, but what about a protected category I haven't thought about?
Well, here's the quickest way to do it. Run your model and then actually use some common sense to look at your results. Don't assume that everything that comes out of your machine or your computer or your algorithm or your artificial intelligence model, don't assume everything is correct, because bias in, bias out, garbage in, garbage out. So basically do a frequency analysis of your data. If you notice that 92% of your data is skewed one way, then you may want to rethink about taking the bias out of your model. You can't take bias out of a person, but you can take bias out of a model.
Do you think you're more optimistic about the potential for AI to, let's say, de-bias society? So like, in the sense that it is very difficult for us to overcome maybe the kind of biological circuitry that makes us naturally amenable to certain types of biases or susceptible to certain types of biases. But maybe a computer to not do that.
Well, I think that, because of, keep in mind that artificial intelligence has been around since the 60s. I mean, thanks to gentlemen, like Jeffrey Hinton, I mean, these things and neural nets are something that have been around for decades. Unfortunately, we didn't have the computational power to be able to run these things. And thanks to a company like NVIDIA and some really great Intel chips out there, now we can. Now we have the girth, now we have the power to be able to run these things. But we don't have enough talent out there to be able to fill all of these positions that are available for machine learning and artificial intelligence and data science. So the colleges are out there trying to ramp up quickly, get all of these people, out into the marketplace. But you can't do this on a 6 weeks course. I mean, you can learn. Your courses are great. Some of the things that you guys are doing are fantastic. All of the things you guys are doing are fantastic. But you also, when you teach people, you let them know this isn't the only thing you need to know. This is just part of your learning. So don't take a 6 week course and then think you're a data scientist, or you're an artificial intelligence engineer, or you're a machine learning expert. I've been doing this for 21 years and I still learn something almost every day. There's always a new line in Java or JSON or Python or Anaconda or something that keeps me learning all the time. And when I don't get to learn, I'm not a happy camper. So, I mean, continuously learn. Look to the experts who have been doing it for many, many years. Don't just look to someone who's, wanting to sell wares. So what they say, if you sell hammers, everything looks like a nail.
Mm-hmm.
So I do think that in the future, machine learning will be very positive. Do I think that artificial intelligence is going to create a bunch of people that's going to take our jobs and they're all going to be run by robots? No, I don't. I don't think that artificial intelligence is going to make a big, huge impact in the next 5 years. Maybe in 20 years, it could potentially make an impact. But right now, it's being used for trivial tasks like chatbots and, automatically doing this, that, or the other thing. Yes, if you have an enormous amount of data and more than what you could possibly do analysis on a daily basis, use machine learning to be able to train the machines. But look at your results. You have to always kind of go in and help out these programs. You can't just let them run forever and not ever go in and make changes. They need to continuously be modified because things change in the world. And if you assume that your machine learning that was written 5 years ago is fine, you're wrong. You should every 6 months, maybe even every 3 months, go in, validate your data, run it on another sample set. These things work perfectly in college setting because you have pristine data. So just because you've made your artificial intelligence or machine learning program work in college, don't think that you're going to get a job at Discover and be able to do the same thing. Because my first boss right out of college said, forget everything that you learned in college, because this is the real world. There's no normal distribution and everything is not pristine. You're going to have to do a lot of what we call data wrangling. And you have to clean your data, and that's a big, huge chunk of our job. Is it sexy? Heck no, it's not. But is it necessary? Absolutely. So, I mean, for data scientists, new young data scientists that join the field and they get discouraged because they thought it was going to be the life of the party, hang with it. The first couple of years is about learning. The next 3 or 4 years will be about implementing. And the next, 10 to 15 to 20 years will be about honing your craft, becoming better and better and better at what you do. You'll make better models in 5 years than you make today. And in 10 years, you'll make better models than you make 5 years from now. So always learn, always improve, always validate your model. Don't assume that you can just set it and forget it.
Yeah, wise words. So I want to thank the speaker for joining us to this wonderful afternoon. And I want to thank our audience for participating and joining the conversation. I really hope you enjoyed it. If you're interested in hearing more about our programs, our free data science fellowship for PhDs and master students, our online courses for working professionals or corporate training, you can go online to our website, www.thedataincubator.com, to learn more. And do go actually sign up for future events, because we're going to have more conversations like this in the future. All right, thank you so much, Carla. I really appreciate you taking the time.
Oh, thank you. You have a wonderful day, and love your show.
Thank you.
All right, have a good one, my friend.